then we should be live. But I require some kind of confirmation. There we go. Old Timer says I'm live. Technophile, hope you had a nap, Fraser. I don't think I could educate people for multiple hours starting at 10 p.m. I had a good night's sleep last night. So not a nap, but a good night's sleep. It is definitely the hardest stream for me to do at 10 p.m. Like, I'm normally already asleep by 10 p.m. So the fact that I'm doing this now is, I'm just, like, how do we provide the live stream experience to a spherical planet? So this is the solution. This is the solution that I have come up with. The one that sometimes gives me my morning time, and sometimes it's in the middle of the night for me. But this way, different parts of the world get to have the live stream at a time that is convenient for them, at least once a month. So, well, I hope you all had a fun New Year's, and of course, we live in interesting times right now with what's going on with the country to the south of me. But it has no bearing on space. Well, I guess it does have bearing on space, but has no bearing on the universe. I just watched Dune and Dune Part 2 with my wife, and it was great. And now I'd already seen it, but we watched them back to back. So, and they were terrific. The special effects are so good, and we watched it in 4K. And the special effects are just so good. Oh man, such a great movie. Okay. Hey, there we go. We've got some people in Canberra, in Perth. This is awesome. This is why we're doing it. Okay, so if you're wondering what it is that you have stumbled into, this is going to be another one of our live stream question shows. This is the raw material that we then blend up and turn into the question shows that we publish on the channel every week. This show is 2 hours long. Hopefully my energy will hold out. My brain will hold out. Yeah. So 2 hours. So it'll end at midnight my time. So a few ground rules. First thing is I try to give emphasis to the people who've never had a question answered before. So if you've never had a question answered, I like your chances. Remember that I am a journalist, not a scientist, so I cannot provide you any opinions about scientific matters. I can only explain the scientific consensus. And then, just put your question in once. I see Zapvan is here, so they can put that into the database so I can see them. So we've got your question. So don't put it in multiple times. But, if I don't answer your question, it's not personal. We get a lot of questions every time we do this, like usually about 150. And I have time to get through about 40 or 50. So, so I'll try to get to sort of like give each person one chance to ask a question. So yes, like a whole bunch of questions. I probably am only going to grab one and then sort of move on to get to the people who haven't had theirs yet. Yeah. So, and then of course, like if it's the same question that we get a lot, then I might skip it. So there's all kinds of reasons why I might not answer. I might not know the answer to your question. It might require more math. And because this is a live format, I can't do the math. So yeah. Okay. Jimmy James, I will not hold out for the whole stream. Now go to bed. Go to bed. Okay. So go ahead and put any questions that you might have into the comments, and we will get cracking. UK 6 a.m. Yikes. Okay. The film. Hey, Fraser, can you explain a Thorne-Zytkow object? Sure, I can take a crack at it. So a Thorne-Zytkow object is a theorized object where you have a neutron star ends up inside a red dwarf. And it was sort of theorized by a couple of researchers by the names of Kip Thorne, obviously, classic, and Anna Zytkow. And this was actually back in the 70s. And they sort of made these predictions that what you might see when you get this weird combination, that you might get like some kind of drag between the neutron star and the sort of layers of the red giant, and that would sort of change the characteristics of the supernova when the red giant goes off. And a lot of the most massive stars are in multiple star systems. You've probably heard this saying that the most stars are in multiple star systems. And that's not actually true. The types of stars that we can see with our eyes, stars like our sun, stars that are much larger than the sun, those tend to be in binary, trinary, multiple star systems. Red dwarfs are the most common kind of star, and they tend to be solo. So in fact, most stars are in single star systems, but the big stars are in multiple star systems. And so you will get, when you have two giant stars in orbit around each other, one of them will detonate as a supernova and turn into a neutron star. And then the other one will detonate in its own good time and probably go through this red supergiant phase. You can end up with a neutron star inside the red giant star. Now, this has never actually been seen, although there was a supernova, or it's a gamma ray burst that was seen about a year ago, and sort of had the characteristics that could be one of these objects. That, it appears that like a neutron star or a black hole fell into the atmosphere, or the surface of another star. And so they saw this sort of really strange characteristic, and I forget the exact sort of like the exact signal that they saw in the composition of the supernova as it went off, but it was like it had never been seen before, super rare. And so they think that there was some kind of interaction where a neutron star was inside the envelope of a red giant star. Carl Smith, has the Monstera deliciosa flowered and fruited yet? No, it's never flowered nor fruited, which is too bad because that would be awesome. Did we get a flower on the other one? So this is a cutting from my wife got this guy off of Facebook, and there was like, it was pretty old, and it had really filled its pot, and so she separated it into a bunch of separate plants. We ended up with 3. So there's one here, there's one out in the living room, and there's one that I gave to one of my kids. So and none of them have flowered or fruited yet. Ayusha Growl, is there a world where local astrophotographers can get paid to do astrophotography? So there are astrophotographers who make a living from their astrophotography. They're selling prints usually, or they are selling the rights to their photography for books that are about space and astronomy, or they're selling their photos for the rights for like documentaries and things like that. So I don't know what the market is like today. So when we did our book on astronomy, the Universe Today Ultimate Guide to Astronomy, the part of the deal that I negotiated with the publisher was that I would be able to go and hire a whole bunch of astrophotographers and pay them money to print their pictures in the book. And so I had a really great community of astrophotographers that I was working with. And so I was able to reach out, and we paid to have the really cool picture on the cover. And then we paid to, I think we ended up getting like 80 or 90 pictures inside the book, which you will have never seen before, which was great. It felt, it felt really satisfying for us to be able to go and give work to astrophotographers. And so like there are a couple of astrophotographers, like a handful. I think, some of them have galleries and like in Las Vegas and things like that. And so some have Patreons that you can follow, and there's like a subclass, which is the people who are taking images of rocket launches. There's a few of them who are able to turn that into a career, but it's a long shot. There's not a lot of work in it. And so, you've got a lot of people who do this for free, who do this for fun. So, if you're looking to make a career being an astrophotographer, good luck. I don't know if it's going to really pay off, but I mean, who knows? I mean, I made a career writing about space and astronomy, and then turn that into podcasting about space astronomy, and doing videos about space and astronomy. So anything's possible, I guess. Werner von Kerman. Fraser, you talk a lot about the solar gravitational lens. What do you envision a mission there looking like, and when do you think it would be feasible? Yeah, I mean, the solar gravitational lens is the new Lagrange point. We get less Lagrange point questions, and now we get a lot of solar gravitational lens questions. And the challenge of the solar gravitational lens is that you have to get out beyond 500 astronomical units from the sun before you start to get that lensing effect. And of course, it's only on one target. 500 AU is a long way away. The Voyagers, I always try to remember this number. It's like 100, isn't it? $170 AU. Okay, all right. The Voyagers are over 150 astronomical units away from the sun. So they are like a quarter of the way to the solar gravitational lens, and they were launched in 1977. And you would think like we've got much faster technology today that could allow us to get out there, but we kind of don't. The technology that was used, chemical rockets, that was used to get the Voyagers into its current trajectories, where they did a flyby of Jupiter, flyby of Saturn, and they have been coasting ever since. That is the same technology that is being used for the Europa Clipper, for the ESA's JUICE mission. All of the outer solar system missions that have been sent in the last couple of decades have used the same techniques. New Horizons did a flyby of Jupiter, and it's not going to go as fast as the Voyagers. So now there are other technologies like ion engines, and they can get you going faster, especially if you just keep running the ion engine for years and years and years to get you up to speed. But we're probably going to need a new kind of propulsion system to make it a feasible mission. Now, I've interviewed Dr. Slava Turishev. He's the sort of the mind behind the solar gravitational lens concept. And he thinks that the best solution is probably going to be a solar sail, that you drop a solar sail down towards the sun, it gets really close, and when it gets really close, it unfurls the sail, gets a tremendous speed boost from being so close to the sun, and then that carries it out away from the sun and can kind of drop that time down into the, 20-year range to be able to get out to the solar gravitational lens. Other people have been proposing things like plasma rockets or even nuclear rockets, but you need something that can give you like either a super fast kick or can just keep firing for a long time. And the problem with chemical rockets is they just, they give you a good acceleration, but you burn through your propellant really quickly. So at this point, like when feasibly will we be able to have a mission out to the solar gravitational lens? We will probably be ready to launch one in the next 20 years if we really put our minds to it. And then we'd be looking at 20 years for it to get out to the lens. So in the 2070s, 2080s, maybe? I know. You want it now. I want it now. Veildarg. Seems like channels like the Angry Astronaut are in need of money, tend to start catering to the "that's not a comet, it's an alien ship" crowd. What keeps you going that route? So, like, I don't want to cast any aspersions on any other channels, so I don't know what their motivations are for doing what they do. I kind of just don't watch them. So what keeps you from going that route? I mean, like, my job as a space journalist is to report accurately what's going on in the universe. And, generally as a journalist, right? Like you look for sources that are reputable and you report them. And if you make a mistake, then you own up to it and you sort of cultivate what are the most useful and good sources that you can get your hands on. So generally for me, it's journals, public, scientific journals. It is researching and interviewing the scientists themselves, or getting the news from sources that are reputable, like universities or NASA space agencies, or people who work with space agencies, or representatives from the companies that are doing this kind of thing. So, it's relatively straightforward. It's literally just called journalism. It's like what journalists do is that I think your job as a journalist is to report the truth, to report as factually as you can what is going on. And that can be boring. Like sometimes I report on null results. People looked for a planet and they didn't find it. Like that is the opposite of people look for a planet and they found it. Or people discovered something amazing. Or there's an alien spaceship moving through the solar system. So, and it's your reputation, right? Like the reason that you want to try to report on things that are factually correct is that you want to be able to do this for a long time. You want to be able to have a career. It's the right thing to do, like for starters. I think we have enough nonsense and people who are spinning their own narratives for their own personal reasons in this world already. And so I think, back in the day, journalism had a reputation. Journalism was considered a thing that was a good career, was something that you could trust. And so I think the way that I get, the way I run my business, the business model that I have chosen is the one where I just build as much trust as humanly possible among my audience so that if and when we make mistakes, which we do plenty, then we are afforded an understanding from the audience. But in general, if people want, if they hear us say something, then they feel like they can trust it. So yeah, I mean, I think, I'm like, I get obsessed about various topics, and the thing that I'm obsessed right now with, and we've got an interview that's coming out tomorrow, so you'll sort of see that, is just this loss of trust in expertise, this loss of trust in people, in scientific consensus, in people being good at their jobs. And I think, part of it is just what you get when you have huge communities of people online kind of crashing together and interacting with each other from around the world and sharing their cultures, you're going to get this weirdness pop up. But I think there are also people who are, looking to sow dissent, looking to drive people apart, looking to make people feel aggravated and angered by and othering people in their community. And I think that's something that we need to fight against. So I would much rather continue to try and bring people together as much as I can. So, it's super, like, it doesn't even occur to me. Like, literally doesn't even occur to me to, like, not just report factually as best I can. Like, that feels like that's the only thing you should be doing and can be doing. And anything else literally just doesn't make sense to me. Bellberg saying the channel made multiple videos letting its viewers know that it needed money. So I'm like, I made a big video telling you that I needed money, right? So like, I think, all video channels, all media right now needs money. It's carnage out there. Wyatt. What are the chances that Europa Clipper detects the presence or possibility of life? Is it even intended for that purpose, or is it more of a mapping and exploration mission? Europa Clipper would have a hard time detecting the presence of life, but it's not impossible. The main purpose of Europa Clipper is that it's going to be doing a bunch of passes by this moon of Jupiter. And it's going to be, as you say, mapping out the surface in sort of higher resolution than has ever been done before. It's also equipped with a lot of other scientific instruments like a magnetometer, like spectrometer. It's going to be able to analyze the composition of the surface on the ice. It's going to be able to measure the interactions of Jupiter's magnetic field with Europa and sort of the environment around Europa. And the most interesting, exciting thing is that it has a ground penetrating radar system. So it's going to be able to send signals that will be able to penetrate down through the ice, bounce off various structures under the ice, and then come back up to the spacecraft. And so that will theoretically allow it to map out the internal structure of Europa. Now, it all depends on the thickness of the ice. If there is a liquid ocean underneath, then it might not be able to reach the ocean, but it might be able to find pockets of water and sort of understand, is it just solid ice, there's no pockets of water underneath, or is it like Swiss cheese? Is it tons and tons of pockets of water? So that's a thing that we don't know, and that's what its main job is going to be. Now, the really kind of like interesting thing that, this is another way. All right. So one of the big uncertainties right now is whether or not Europa has geysers in the same way that Enceladus has geysers. Like, we know that there is water ice spewing out from the south pole of Enceladus into space. And that's ideal, because then you just fly through these plumes at Enceladus, and you have various instruments on your spacecraft that can detect the presence of various chemicals in those plumes, and then that might give you a sense of whether or not there's the conditions for life. Not necessarily that there's life, but the conditions for life. That would be very useful. While we don't know if there are those plumes on Europa, it's suspected that they might be there. And so if they're there, Europa Clipper will almost certainly find them. And then if it finds them, then it can perform analysis on those plumes. And hopefully you're going to be looking for the kinds of things like hydrogen gas that is suspended in the water, which is essentially food for bacteria. You're looking for organic chemicals that are coming out of you're looking for organic molecules that are coming out of these plumes with the water as well. That tells you, okay, there's lots of organic material down there in Europa. So, I wouldn't, finding life is going to be so hard. So I don't think that anyone would say, oh yeah, no question. If there's life on Europa, Europa Clipper will find it. Instead, just like we saw with Curiosity and Perseverance, it's this long journey where you're looking for the conditions for life. You're looking for the elements, the chemicals that make up life. And maybe that gets you closer. But I think, to really truly search for life on Europa, we have to get down under the ice. That's going to mean boring down through tens of kilometers of ice to get down to the water beneath and send some kind of submarine in there to look around. Pura Vida Hoser. What's your bet on the design of the next space station? Do you think it'll start going up before the deorbit of the ISS? How much will they reuse? So your name. So are you like a Canadian living in Costa Rica? That's like my guess. Anyway, tell me. All right. So right now, the United States has no plans to build a space station. So by 2030, it's expected that the International Space Station will be deorbited. The Russians have said that they're going to extract their portion of the station, and so it'll just be the American version that's going to re-enter the Earth's atmosphere. Many people are skeptical. I am skeptical that the Russians are actually going to be able to pull this off, and that probably the whole thing is going to come down. The follow-on space station that the United States was planning to build was called the Lunar Gateway, and this is going to be a space station that was going to be in a halo orbit around the moon, sort of essentially like gravitationally halfway point between the Earth and the moon. Non-natural physical halfway point. And so you would see the Artemis missions using the gateway as a way to make trips to the moon more reusable. So you would fly to the gateway, astronauts would set up on the gateway, and then they would fly from the gateway down to the moon and then back. But under the current administration, it really looks like the gateway is being canceled, even though a lot of the parts have been built. So whether or not that will ever be actually completed and actually launched is unknown. And there won't be a space station. So you're going to have to look to other countries to build space stations or private groups. So obviously the Chinese have their space station and they're planning to expand and extend it, bring on more partners to be able to have more people on board. And then there's a bunch of private companies. Vast is one that is working on a pretty cool idea for a space station. It's very modular and looks very, the pieces look very sort of like they fit together, and it's, you can sort of see how they would just keep expanding it as they get more funding. But that depends on there being a business. And I think, like it's possible that NASA would be a really good customer for something like a private space station, just in the same way that they've been a good customer for a privately built space capsule that gets you to and from the International Space Station, that they are a good customer for privately built spacecraft that will carry scientific instruments to the moon. You can imagine that they would pay some commercial partner to be able to send their astronauts up to some station component where they can do a bunch of science experiments for NASA, but not have to sort of foot the entire bill of launching the station and manage its operation. So I think that that's a model that NASA has tested so far and seems to work. But right now, there are no concrete plans. There just aren't. A bunch of people say they're going to do this. There are plans, there are press releases, but I haven't seen any players who are putting serious money into this who are absolutely guaranteed in the way that, say, NASA saying we're going to build the space station are. Indoor teacher. How do you feel about Elon Musk and his impact on space travel? Him and any other rich space tycoon? Do you think they're too rich, or should they be able to continue to expand? I'm ambivalent about the various billionaires building their spaceship companies. I used to be a lot more enthusiastic about it, and have sort of, I don't know, gotten a little more jaded over time. So what do I think? So just like in general, like imagine you just have like your generic billionaire who is obsessed with space and wants to take their money and turn that into technology, rocket technology. I think that's fine. I think that's good. I think, you know, as a fan of space, as a fan of space exploration, I would like to see more missions, more exploration of the solar system. I'd like to see us use space better. I'd like to see a base on the moon. I'd like to see a base on Mars. I'd like to see, humans set foot on various worlds around the solar system. And that's going to take rockets. It's going to take hardware. It's going to take technology. It's going to take a lot of development and investment. And there's only so much of that the governments are willing to do. NASA, ESA, JAXA, the Chinese Space Agency. And if private companies are looking to step up and have a way to develop a business model that will make that sustainable, then I think that's a perfectly viable business, right? Like we didn't have a problem with United Launch Alliance building rockets, the Deltas and the Atlases and so on. And so SpaceX has dramatically decreased the cost of rockets. They've developed and advanced the technology of reusable rocketry. And now it's turned into a gigantic business. And so, it's sort of self-sustaining at this point. We're waiting to see what happens with Blue Origin, with Jeff Bezos. But I think, they are transportation companies. And the sort of amount of initial investments that's required to create a new transportation company that is going to space is huge. And rocket companies go out of business. Like that's mainly what they have done in the history of humanity. Space exploration companies, rocket companies have just gone out of business. And there's like a laundry list of companies that have gone out of business. But SpaceX was the one that was able to pull it off. So I think on that front, I think they're fine. Now there are downstream consequences that I think, there are externalities that these companies are putting on the planet in society that are not being properly factored into their business models. Environmental issues, light pollution, pollution for radio telescopes, space debris, cleaning up space debris. Like there are all of these issues. And, a lot of the times, as with any new industry, the externalities aren't properly priced in. And then we realize what they are. And generally it's the governments that tend to have to clean this up or pay to have this cleaned up or whatever. So if, I would prefer more sort of regulation and time was spent making sure that the externalities were properly factored into the companies before they sort of filled the sky with 100,000 satellites, because, that's going to be not great for astronomy when these mega constellations get complete. But that doesn't require a billionaire, right? Like I think you could have just a company that is run by a bunch of shareholders, no billionaires involved. You may not even know the name of the person that's running the company. It just happens to be that two of the big space exploration companies were run by billionaires. So I kind of don't see that being a factor. It just happens to be how this played out this time. Well, Georgia, can we get a how close are we to space orc invasion update? Like the space orcs from Warhammer 40K? I don't know. I'm trying to think of a witty thing to say, but it's late. Some kind of like Warhammer 40K army reference about if someone's hasn't painted their figures, yeah, it's not coming to me. Astro Space Boy, could you comment on an idea for a sci-fi book where scientists are able to create a Could you comment on an idea for a sci-fi book where scientists are able to create a mini wormhole, transferring the atmosphere from Venus to Mars, terraforming 2 planets in one go? Like, if you had a wormhole, there are so many things that you'd want to do with that wormhole, as opposed to necessarily terraforming Venus and Mars. But let's say that's what you wanted to do. Well, the problem is that you would have too much atmosphere at Venus to be able to use it over at Mars. So the atmospheric pressure down on the surface of Venus is 93 times the atmospheric pressure that you experience on the surface of the Earth. Mars is very small compared to the Earth and compared to Venus. And so you would take, I don't know the exact number, maybe an Earth's worth of atmosphere. Like, say you really want to put a thick atmosphere around Mars. So you take 1 Earth's worth of atmosphere. You still got a lot left on Venus. So you're going to have to dump it out into space. All of it. Because it's just carbon dioxide. Although you're going to lose the nitrogen. And the nitrogen is very important. So how do you filter out the nitrogen and keep it on Venus while you get rid of all of the carbon dioxide? It's a big job. And if you got a wormhole, there must be other uses that you would want to use for your wormhole, like getting from the surface of the Earth out into space, or I don't know, going back in time. Like, there's all kinds of things you'd want to do with a wormhole. Feels like a very, like, if what you want to do is terraform Venus and Mars, they are separate worlds, both of which have gravity wells. And so you're going to need to tackle each one separately. Linda Green, thank you for explaining the externalities. Yeah, like, I think that a lot of our problems on Earth come from people ignoring or not taking responsibility for the externalities of what they do. Like, if instead of paying the garbage company to pick up my garbage, I take my garbage and I dump it on your lawn, then I have saved myself some money, right? I no longer have to pay for garbage pickup. Maybe I'm saving myself $100 a month, and you have a problem, right? I have taken my externality and I've given it to you, and that's not fair. And really, right, I have to pay my $100 to get my garbage picked up and have it taken away. And so that, what seems fair on the small level still works at the large level across the entire planet, right? If I run a factory and I dump pollutants into the stream, and the stream goes out into the ocean, and the ocean causes fish to die, and that ruins the fishing for a community, I have, through a long chain of events, essentially passed off an externality. I've saved money at the expense of other people. And that we know what most of these externalities are. We know what the externalities are for the cigarette companies. We know what they are for carbon dioxide. Like, we understand how much carbon dioxide is being put into the atmosphere. We know what the consequences of that are roughly. Like, you can do the math for how much temperature rise will happen on Earth on the back of an envelope, right? And there'll be sort of local differences, but in general, you can calculate what that temperature rise will be. It's a very known property of gas. And so, when you put carbon dioxide into the atmosphere, somebody later on is going to have to clean that up. and they're going to have to pay for it. We often just live our lives. And so I think that a lot of people argue about things being political, and they're not political. Like literally, they're just people are not being responsible for the externalities that they're producing. And we're looking at the space debris, space junk problem right now as another one of these things, which is that we're putting satellites, we're putting boosters into orbit. They're going 28,000 kilometers per hour, and you have to get rid of them, or they're going to break up, crash into other things, and cause damage to people's satellites. Like, what do? Right? You launch a satellite, your satellite gets taken down, gets destroyed because somebody didn't clean up their space booster. Externalities. So yeah, I think if you just like sit down and calculate the externalities for whatever it is that you're doing, then I think we live in a much fairer planet. And then I think you can have your capitalism, right? You can have business, like a business that actually properly accounts for all the externalities is, probably good for humanity, right? It's the ones that hide it, pass it off, obfuscate, try to, gaslight you into thinking that that they're not causing externalities, that it becomes a problem later on. Procs are high from the west side of the island. Does the moon have seasons? Wow. So that's a great question. I'm just like, I've never been asked that question before. So I'm just sort of like thinking through the orbital mechanics of this. So the reason that the Earth has seasons is that the Earth is tilted at 23.5 degrees. And so during the summertime for the northern hemisphere, the Earth is tilted so that its northern hemisphere is sort of facing towards the sun. And so you get more direct sunlight. And then in the wintertime, it's tilted away from the sun. The moon orbits around the Earth's equator, but not exactly. It's sort of inclined at 11 degrees. So sometimes it's higher and sometimes it's lower. And it has its own axial tilt. I would have to I'm sorry, I would have to sit down and really think through the orbital mechanics of this, because nobody has asked me this question before. But I'm just kind of thinking, right? So when the Earth is tilted away when the northern hemisphere is tilted away, then the moon is going to be following, and it's also going to be showing its south face. So it feels to me like it would experience seasons, but obviously it doesn't have an atmosphere. So, but will you experience more direct sunlight if you're on the north pole of the moon? Yeah. Yeah, because the moon's axial tilt is about, so Astro Space Boy is saying the tilt is 1.5 degrees, but that's 1.5 degrees off of its orbit, and its orbit is going around the Earth's equator, but that's tilted 11 degrees. So, yeah, I'm sorry. It's an awesome question, and I now need to sit down and figure this out. So, let me get back to you. The Bunny Lover. Any idea of how large a telescope could fit in the Starship? I've seen ideas floated around for telescopes in the, if it's just a straight up non-folding telescope, then the fairing size of Starship is about 9 meters. Let me just confirm that. I think it's 9 meters. Yeah, 9 meters. Okay. So the fairing width of Starship is 9 meters. And so you could put a telescope inside. Like, it wouldn't be 9 meters, but maybe it would be 8 meters. And so think about a telescope that has no folding telescope parts, like, say, the Herschel telescope or the Hubble Space Telescope, right? Hubble is 2.6. No, Hubble is 2.4 meters across. So you can have a telescope that is 8 meters across, which would be bigger than James Webb. James Webb is 6.5 meters across. And you wouldn't have to build this complicated folding telescope. You could take a telescope that is about as big as the Gemini North, the Gemini South, and just put it inside Starship and launch it in one go. Now, if you built a folding telescope like James Webb, then you could probably go to 15 meters, 20 meters, probably even bigger, if you're willing to, spend an amount to have it folding. So 8 meters if you didn't fold your telescope, much bigger if you had it able to fold. Pete Rund, how has global warming affected your winter night sky view in Canada over the past 10 to 20 years? Has there been more or less cloudy nights? I mean, the effect for us here in Canada is sort of the effect that everybody's seeing. It's climate change. So, our winters have become a lot warmer than they used to be. So we used to have like a lot of cold snaps in the winter. Like, I live on the West Coast, so we're the Florida of Canada. Much warmer weather. There are palm trees in Victoria, but it was fairly dependable that you would have some cold snaps. You would have a snow a couple of times. Mostly it would be rainy and wet all winter long. And now it really varies. So this winter so far, I think we've had one night that got just below freezing. So far, November, December, now we're into January. Now there could be some cold days coming, but we just haven't had any, like, literally we had one day that was -2. And I live a little bit up in the mountains, a little higher altitude. So I don't think at the lowlands it's even gone below freezing this winter, which is super weird, very unusual. But last year we had -20. So it was really cold, colder than I had ever experienced it. And then the year before that, we had snow, ridiculous amounts of snow. We must have had 2 meters of snow on the ground, like, at one time. And I've never seen that before in my life. So what we've gotten here is the weather has been bizarre, but to not be able to see the sky at night, that's pretty normal. That's a West Coast Canadian winter for you. We can have it rain every single night for a year. No, sorry. We can have it rain every single night for a month. In fact, like, I got the new telescope and I really want to see Jupiter. And every night Jupiter rises around 8 o'clock. And I take the telescope out and I set it up and I let it cool down and I'm ready. And there's like a thin haze on the nights where we've been able to try and look at Jupiter. We can see it. We can see the moons. I can't quite see any features on the planet. There's too much haze in there. And it's been very frustrating because it's probably been like 5 or 6 nights of it being this light haze. So I haven't had a clear enough night to be able to see Jupiter with my telescope so far this winter, which is quite frustrating. Chiroptal. Fraser, I've heard you mention that you see humanity inhabiting the entirety of the solar system. Do you see us colonizing gas and ice giant moons or more interplanetary space stations? Yeah, like, people always think that I'm like Mr. Buzzkill about human space exploration. And, clearly someone was listening, which is that while I may feel that our short-term space exploration plans are going to be less exciting and less adventurous than we were all homing than that our short-term space exploration plans are going to be less adventurous and less exciting than than science fiction had led us to believe. Long-term, we're going to completely dominate this solar system. It feels kind of inevitable, and that inevitability just comes from our sort of continual growth of our economy. You can look at the growth of the economy for thousands of years, and it is this exponential growth that just keeps going. And now we're growing at, say, 2% per year, and you chart that forward hundreds of years, and that's more than planet Earth can support, which means like either we go extinct, we flatline our growth, or we go to space. And I prefer space. And you just keep going. And within a couple of 100 years, we are using a large amount of all of the materials in the solar system. Now, what exact form that's going to take, we don't know. Hopefully we'll have the wisdom to do that in a way that is, ethical. But, look at how we treat planet Earth, right? Like we just sort of move into a space and we just take over, and we just keep taking over and getting bigger and bigger. And, that will probably do to space too. So like what exact form is that going to take? We don't know. The inner solar system, Mercury, Venus, Earth, Mars, the asteroids, they have the metal, the rock. The outer solar system, the moons of Jupiter, the comets, the Trojans, they have the ice and all of the volatiles. And all of these are required for us to be able to continue on in our economic growth. And so like what exact form will that take? I always say that gravity wells are for suckers. And so my preference is that we don't go back down into gravity wells, that we do build those giant space stations, those O'Neill cylinders. I think that's a sort of cooler idea. And then we can kind of leave the planets and have them be wildernesses that we can go down and visit. I think, there are a lot of concerns, health concerns about trying to live long-term on a place like Mars or even the moon. There's, we don't know what lower gravity is going to do to the human body over long periods of time. One possibility is it's fine. We can go down to 1/3 gravity on Mars, 1/6 gravity on the moon, and that's enough gravity for the human body to function properly for an entire human lifetime. But another possibility is that it's not. That you can't gestate babies. You can't grow them to term. You can't, have your bones form properly in that lower gravity. That anybody who tries to live on Mars for any long period of time is going to experience tremendous health effects. And so instead, you go to space where you just rotate your space station. You get to dial in the exact gravity that you want. So who knows what form it's going to take. But I think, seeing the rise of technology, it seems amazing. It seems like it's going faster and faster and faster. And when you take sort of a exponential perspective on the growth and the speed of how things are growing, then things make more sense. They're still baffling, but they make a little more sense. And so you can kind of take that idea of exponential thinking and think about the future of human society and get some glimpses of the directions that you think humanity is going to go in. But the specifics are a mystery. Astro Boy SpaceX, what launches have you attended? So I attended a space shuttle launch, but the shuttle didn't launch, so I had to return without watching it. And I attended the launch of the OSIRIS-REx mission. So I was there for that, and that was cool. Um, Indoor teacher. All seriousness, what are the odds that a flat Earth actually exists? Somewhere out there is a flat discus planet. So the problem is that the gravity of any object will try to pull it into a sphere. And so this is a thing called the hydrostatic equilibrium. And generally you will get hydrostatic equilibrium on any object that's bigger than a couple of 100 kilometers across. So a large asteroid, a moon of Saturn or Jupiter, you're going to get it pulling itself into a sphere. The moon is several thousand kilometers across, and so it has absolutely pulled itself into a sphere. So no, you can't get a flat planet. Anything, if you have a flat discus planet, it will just pull itself into a sphere again. Everything wants to be a sphere. Just looking for questions. Sorry. Billionaires has asked a bunch of questions. Billionaires, do you think humans are ready or will be living on the moon or even Mars in 2030 and beyond? People always ask me when we're going to be having humans on the moon or Mars, and who knows, right? I think if you go back to 1969 and people watched Neil Armstrong's, if you go back to 1969 and people watched Neil Armstrong take his first footsteps on the moon, then you would have thought, okay, this is it. We're a spacefaring civilization now. And it would only be a couple of, years before you had a permanent base on the moon. But of course, the reality was much different, that we didn't go back. It took 50 years for us to potentially go back to the moon. And now you've got a bunch of people that are potentially going back to the moon. But, all of the plans are still kind of up in the air and could get canceled at this point. Maybe the Chinese are sort of the one that are farthest along, I think, in, their plans for 2030. NASA was planning, with its Artemis mission, but we're still waiting to find out if the Starship is going to work as a lander, maybe the Blue Origin, maybe there won't be funding. We don't know, right? At this point, everything is kind of a mess. But I could imagine there being a base on the moon in the 2040s, 2050s. When will someone set foot on Mars? Some people say that it'll happen in 2024, last year, but it didn't. So, who knows when that's going to happen as well. I think if you go the NASA route, it's going to happen after people go back to the moon, but it's going to be complicated and expensive and have a lot of hardware, and it's going to take a while. So, probably into the 2040s, 2050s. So I would say, 2060, somebody will probably have set foot on the moon and Mars. Probably. Will we be living there? Only in like a space station, only in the way that people live on the International Space Station, which is that they do tours of duty and then they come back. I don't think anyone will move to the moon or Mars and that will be their home this early on. Diane Feinstein. Someone should invent a nuclear-powered Comet dash cam so we can all hitch a live feed ride on the next 3i Atlas type comet that we encounter. So we've got kind of the next best thing, which is that the International Space Station is, Sunday night. We've got the next best thing, which is that the European Space Agency is planning a mission called the Comet Interceptor. And this is going to fly probably in 2029 out to the Earth-Sun L2 Lagrange point. So the same place where the James Webb is. And it will loiter there, waiting for another interstellar object to pass through the solar system, or like a long period comet, but an interstellar object would be even better. And when one is sort of within its flight path, within its cone of reachability, then it will fire its engines and it will try to make an interception of this object as it's passing. And so we will get close-up images of an interstellar object for the first time ever, which will be mind-blowing. Like, imagine if we could see close-up images of 3i Atlas or Oumuamua. Like if I had to pick an interstellar object that I would like to see up close, it would be Oumuamua. That thing is so weird. So that is sort of the most practical version of this that we have. Now, if you actually were able to put a camera down onto the surface of one of these interstellar objects, that would be incredible, right? You would be able to see a better image of the object, but it wouldn't let you sort of have a better view to the cosmos. Even though these are interstellar objects, they came from another star system and they're going to be escaping the solar system. They're going to take a very long time to do it. The Oort cloud reaches out probably 1 light year, maybe even 2 light years away, halfway to Alpha Centauri. And so even going at tens of kilometers per second, these things are going to take tens of thousands of years to leave the solar system. And so your camera will run out of batteries by then. Oh, that's a great question. David VA, would you prefer that we find aliens first or that they find us first? I would prefer that we find aliens first. If the aliens found us, then we wouldn't be able to have the introductions on our own terms when we felt like we were ready and we felt like we had sort of understood them a bit. So it would be best if we detected their presence, detected their signals, were able to try and uncode their, decode their language, be able to understand them better, get a sense of who it is that we're dealing with. But if they just show up and then, introduce themselves, anyone who can actually make it here is sort of vaguely threatening. We would have to consider it a risk for sure. So no, I would love for us to be able to very passively detect the presence of another civilization before they find us. And then we can just try to plan out what we want to do about that. Hoodlum, do you think AI will be able to solve the 3-body problem? No, I don't like, it doesn't look like there is a solution to the 3-body problem. Like, the gist is that chaos. There's so much chaos in the interactions between three objects gravitationally that any predictions, any models that you create become inaccurate over time. And there are a lot of chaotic situations where small starting changes over time propagate and become impossible to detect. Now, if you've got a much more powerful computer, you're able to do much better simulations, then you can sort of calculate the future paths that these objects are going to take farther into the future, but eventually you're going to require like more computing than is possible in the universe to be able to calculate this, and it's just not worth it. So no, I mean, an AI is just a fancy computer program, and we can make fancy computer programs that can calculate the three-body problem. You can do it on your computer. If you know how to code, you can try to write a program that will simulate three-body interactions. And the problem is that your predictions will not match reality given enough time. And you have to have a better computer, a better simulation, and even that will eventually lose sort of track over time. Technophile 1. Fraser, can you recommend any books or a crash course on journalism? I live down here in the Terran Empire, so I'd like to build my own credibility to fight misinformation. No. I'm trying to think. Like I was not trained as a journalist, right? I was trained, my degree is in computer science. So I just sort of learned my journalism through doing, but I don't know, like it doesn't feel that complicated. Like you find a source who is knowledgeable about a subject. And I guess, knowing who is knowledgeable and who's not knowledgeable is a question. But in general, you can follow the scientific consensus, right? Like that's your default solution. And then report on the discoveries that they're making, sort of understanding that things are not certain, that science changes, science updates its beliefs based on the evidence. And so that's why you see a lot of those weasel words with science reporting. Scientists suspect, scientists believe, scientists might have found the possible cure for blah, 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 right? Like those are the kinds, so that you can then go, oh, turns out they were wrong. Turns out they thought they had the solution, but they didn't. But yeah, I think what good journalism is, probably. So, it's just about reporting it accurately as best you can, Yeah, I can't think of like, you kind of got to feel it in your bones. I don't know. It's weird. But, there's journalism classes you can take. There's journalism curriculum you can take in various universities and stuff, and they'll go through the basics. Get a textbook on journalism. I guess these exist, and then skim through it, read it. It'll cover like the number one rule. And this is funny. So where was I listening to this conversation? Was it the Slate Political Gabfest? Maybe. So in journalism, no, it was. Anyway, in journalism, the number one rule is do not make up stuff, right? Like do not confabulate. Do not hallucinate. Do not make stuff up. That is the unforgivable sin in journalism. That if you work at a newspaper, you work at at some reputable journalism place and you are caught making stuff up, you are fired, and then you probably have your reputation ruined, because the whole point is that people need to be able to trust you. And it is really hard to tell when somebody is making something up. It is impossible if a person is doing a good enough job. And there are these sort of famous examples of journalists who were caught making up their stories, just inventing quotes that they said came from somebody who was on the scene. Because, like, you're on the scene, you're reporting some event, someone, you report that somebody said something and it was very meaningful and it made your story really punchy and really added to it. And it turns out you just made it up because it was easy. And that's really hard to catch as an editor, someone who is, reading the work of the reporters. And so that's why that is like considered the worst sin in journalism. And of course, this is what AI does, right? Like, large language models hallucinate nonstop. They confabulate. They make stuff up. And they say it with authority in ways that are hard, that can be hard for you to double check. And that's why I think, it runs completely counter to journalism, that having a program that is probably making stuff up shamelessly, that has no issue with making stuff up, is such a problem. And I think it's why it rubs a lot of journalists the wrong way. So that's it. Don't make anything up. Whatever you do, just try to stick to facts and report on things that people say, and you should be all right. Church discography. Have you built any cable stayed or suspension bridges on your property? No. No, I'm just wooden bridges with runners and planks on top. There's one span that is going to be like probably 25 feet, like, across. And so we're thinking of using like the deck of an old 18-wheeler, and then just like craning it in and putting it down, and then putting planks along the top so that I can actually drive across it, like take a truck across it. That'd be cool. So, but no, apart from that, I haven't built a suspension bridge on the property. Pete Rund, if you could live comfortably anywhere on this planet, where would that be, based on your belief of the best sky view? So the best skies that I have ever seen were in Australia, without question. You sort of got two things. One is that, we were far away from the city, in the outback, and the night sky is just ridiculous. So clear, so bright. It was just full of stars. And then the second thing is that the really interesting stuff is directly overhead. So where I live in Canada, I don't get a lot of clear nights. So, that's not great. But there are places, in Canada that get more clear nights, almost anywhere. Go to Alberta, you're going to get clear nights in the wintertime. They're going to be brutally cold, but they'll be clear. And they'll be dark. But in Canada, the Milky Way, the center of the Milky Way, is down near the horizon, kind of just above the tree line. And it never gets much higher than that. But when I was in Australia, you could look straight up and see the center of the Milky Way. It was mind-blowing. And when I was there, Saturn was sort of in the area as well. And so it felt very strange to me. Again, for me, the planets pass sort of to the south along this line, the plane of the ecliptic. But there, it was like you were looking directly overhead. And so, yeah, I think, if I was to pick a place for night skies that it's also like comfortable temperatures, like obviously you want to be in the mountains in the Atacama Desert, right? That would be great for night sky, but it would be very cold and very high altitude and very hard to get groceries and so on. But yeah, I would say probably Australia had the nicest skies. There's a very strange argument about ants right now. Ian Cudmore, Fraser, East has dropped new claims of breaking records, and we get a lot of this type of news lately, but there doesn't seem to be much real progress. Does or UT will have anything that explains this? I don't even know what East is. What is East? Can you give me more information? Breaking records, is that on Fusion? What is that about? Yeah, I have no idea what you're talking about. Now I'm searching this. Is that the experimental advanced superconducting tokamak? Okay. When did we last report on that? Let me see. (2018) was the last time we reported on the Chinese fusion experiment. So it's not really a space story, I guess, is sort of like the main reason we don't report on that is that, generally we're reporting on stuff that has to do with space. It's an advanced technology. It's using fusion. The sun uses fusion. So that's cool. It's a physics experiment, kind of, in the same way that the ITER in Europe is. But I just doesn't really fit within my wheelhouse. So, so yeah, just, there's stuff like that. Like there's a lot of stuff that's kind of very tangential to space and astronomy. Do we report on climate stuff, right? It's stuff that affects a planet, the Earth. Exoplanets would experience climate issues as well. So, like that, there's times when I think that that's relevant. Particle physics, is that space, right? Well, kind of, like we detect the cosmic rays and neutrinos coming from the sun. So some particles, in the Big Bang, you're thinking about the sort of fundamental particles that created the universe. And so maybe particle physics and like just like general physics, string theory, so like maybe origin of the universe. So, often I'm, because I'm providing a lot of the story seeds to the writers, the reporting that you see on Universe Today very much matches my personality and my curiosity. And I just am, there's certain stories that I'm drawn to and stories that I'm less drawn to. I'd be very excited to see people make progress on nuclear fusion. That would be amazing. But I'm not going to sort of report on the day-to-day fusion grind across many companies. AJ Mitchell, any thoughts on experiments showing ants recognizing themselves in the mirror? I haven't seen that. I know that roosters passed the mirror test, which is pretty cool. They had a rooster and it was able to tell that it was seeing itself in the mirror, and so it didn't make a warning call when it saw a predator in the air. And then another time it saw another chicken, and then it knew to make the warning call when it saw the predator in the air. And like they'd sort of, had it in some room and it could see an image of a predator in the air, and it, or an image of another chicken versus a mirror, but it was able to tell that it was seeing itself as opposed to like another chicken, and so knew whether to do the warning call or not, which is kind of cool. So, the mirror test just keeps getting passed by more and more entities, which, tells you that there is probably that classic quote, like, what is it like to be a bat, right? Like there's a qualia of experience for what it's like to be an ant, or for what it's like to be a chicken. Different from what it's like to be a human, but it's not nothing. Proxter, are there any plans for refining and producing new nuclear fuel for deep space missions due to its limited lifetime and supply? So right now there is ample material. So the shortage that you're talking about was earlier on in the century, back in the early 2000s. There was a shortage of plutonium for the RTGs, the radioisotope thermoelectric generators, things used by Curiosity, Perseverance, New Horizons. Anytime that you're not, you need a compact power source, you probably want to go with the RTG, and it is this decaying chunk of plutonium that gives off heat. The heat then uses a thermocouple to produce electricity from that. And plutonium is hard to make. It's very expensive, very time consuming, very expensive. And so there was a shortage of plutonium. And in fact, that led to the Juno spacecraft using solar panels instead of an RTG when it was exploring Jupiter. But that blockage has been cleared. And so now there is enough material. I actually got a chance to interview somebody who works with the stockpile, and that they have enough material at this point in the pipeline that if missions genuinely need this, then they can go this route. But in fact, Europa Clipper is using solar panels as well. So is the JUICE mission. So, Juno demonstrated that you can use solar panels to run your mission all the way out at Jupiter. And it's probably theoretically possible to run a mission out at Saturn with solar panels as well. But you probably still want RTGs for a rover, something compact, big, or if you want to go into the outer solar system, like you're going to go to Uranus or Neptune, you probably want an RTG still. Dean Kovacs, are there any plans for another space station after the ISS is decommissioned? No. Novacastria, what are your main hobbies, interests outside of Universe Today and the general space world? So, I think it's come out in bits and pieces from all these recordings that I do. So my wife and I live on Vancouver Island, and we are kind of rewilding a piece of old degraded logging land. So I'm really into kind of reforestation and biodiversity and sort of renaturalizing the property. Mountain bike. Do a lot of hiking in the summertime. I play a lot of video games, watch movies, read science fiction books. I play role-playing games with my kids. Travel. So I think those are my hobbies outside of doing space. Is Jordan, does any object falling into a black hole fall in the same direction along the different dimensions of space? So like when you think about things falling into black holes, just imagine things falling onto planet Earth. That if you were, Earth is a sphere, the gravity of, the gravity is that it's actually a distortion of space-time. But if you sort of imagine it as a force that is pulling things, then it doesn't matter what angle you come in at on the Earth, you're going to fall and hit the Earth, right? If someone teleports you above the South Pole, 10,000 kilometers above the South Pole, you're going to fall and you're going to hit the South Pole. If someone teleports you and you're above the North Pole, you're going to fall and hit the North Pole. Black hole is exactly the same, right? It is the name is bad because it's not a hole. It is we can see or theoretically, the event horizon around the black hole. We don't exactly know what the black hole looks like, but it is a dead star. That is all the mass of a star now compressed into potentially something that is microscopic. Maybe it's the size of the event horizon, doesn't matter. Practically speaking, if you were teleported above the south pole of a black hole, you would fall and hit the south pole of the black hole. If you were teleported to the North Pole, you would hit the North Pole. So think of a black hole exactly like you think of a planet or a star or whatever. Something where the force of gravity, effective gravity, is exactly the same. Just more. Proctor, have you interviewed any astronauts from the Apollo program? Yes. Who have I talked to? Let's see. Talked to Harrison Schmitt. I think that's it. And Rusty Schweikert. So I've talked to Rusty Schweikert for sure. No, I didn't interview Harrison Schmitt. So that was one of the other reporters on the team. Yeah, so that's the only Apollo Air astronaut that I've actually interviewed. And Rusty Schweikert is sort of important because he was the co-founder of the B612 Foundation with another astronaut, Ed Wong. And so they're trying to protect the Earth from an asteroid impact. And so they've been doing a lot of work and outreach in that. And so sort of easy to interview. I've talked to lots of space shuttle astronauts. But I haven't talked to, I can't even remember all the space shuttle astronauts that I've talked to. Maybe 10 astronauts? Yeah. Nova Castro, there's a channel called Dust Ups that you might enjoy. Yeah, I'm definitely watching all of the Sean's efforts at the Dust Ups channel. I have the exact opposite problem from him. We have too much water. Like it just rains and it rains and it rains. And so our problem is dealing with all of the water. Nick Stokes, what is one of your favorite ways of imagining or contemplating the scale in the universe? So it's really difficult to wrap your mind around the universe. And part of that problem is that we know that when we're looking out into space, we're looking back in time. That we are seeing the moon as it looked, a second ago. When we look at the sun, it's 8 minutes ago. When we're looking at Andromeda, it's 2.5 million years ago. And when you're looking at the cosmic microwave background radiation, it is 13.8 billion years ago. And so it's not what's there now, and it's not even where there is now that we're seeing the light that was given off back then, but now that stuff has moved farther away. So, for example, the light that left the cosmic microwave background radiation was 13.8 billion years, but now that actual location of that place that gave off that light is about 46.5 billion light years away. And it's not what we see is how the universe looked when it was 380 million. No, what we see is how the universe looked when it was 380,000 years after the Big Bang. But those places have continued to evolve in the same way that we have here in the Milky Way. That what looks like just this diffuse red glow shortly after the universe has evolved into probably a galaxy that is, the same age and maturity as we are. And it is 46.5 billion light years away from us. And so it's it's really hard to think, to kind of contemplate the size of the universe and not have your brain switch into one of those modes, right? Because like all of the pictures that we see, when we look at pictures taken by James Webb, we are seeing galaxies as they looked 800 million years after the Big Bang, 500 million years after the Big Bang. We're not seeing them as they look today. When we see pictures from the Hubble Space Telescope, we're seeing the Sombrero Galaxy. Okay, now we're tens of millions of light years away, so tens of millions of years ago. It's kind of the same. But the farther away you look, then the more this stuff is now a snapshot of the past. And when we think about the universe, the observable universe, it is sort of like it's a universe of time, because the universe has had 13.8 billion years to send these photons to your eyeballs. And it's not how the universe truly looks. So you sort of, for me anyway, I don't know how it works for you, but my mind just kind of flips back and forth. I think about the universe sequentially in time, and then I think about the universe as it must look today. And I can't hold those two thoughts in my brain at the same time. But both cause wonder, right? Both cause amazement in my mind. Probably more so that we're looking back in time. You know, I can sort of imagine a galaxy like the Milky Way, but just think about events unfolding that we are looking at, and we're seeing slices of the cosmos back in time. That blows my mind. And I have trouble holding it together in my head without just kind of going, whoa. So, you know, you ask me what's my favorite way. I don't know. I don't know if you can. Like, I don't even know if it's possible to not just have your brain break when you try to think about this kind of thing. Mad Million, if 3i Atlas was somehow able to smash into Jupiter, would we notice anything? Yeah, we totally would. So there was a comet that crashed into Jupiter about 30 years ago, 1994. Let me just confirm this. So Comet Shoemaker-Levy 9, 97? Hold on. All right, let me get the exact numbers so I can say this properly. So discovered in 93 and it crashed in 94. Okay. All right. And it was, how big was it? It was bigger though. No, smaller, 1.8 kilometers. Okay. Yeah. All right. So I think it gives me what I need. All right. So we have an example of something crashing into Jupiter, and it was much smaller. It was a comet. So Comet Shoemaker-Levy 9 was discovered in 1993, and it's a comet that's 1.8 meters across, and it got too close to Jupiter, got torn into a bunch of pieces, and then those pieces splatted into the surface of Jupiter in 1994. Unfortunately, we had the Hubble Space Telescope at the time and other Earth-based telescopes, and we were able to look at Jupiter as the collisions, like they happened on the far side. And so as Jupiter kind of rotated around, we could see the bruises that were left by this crashing into Jupiter. And we could definitely see them. When you think about it, like it was a 1.8 kilometer object that had been broken into smaller pieces, and those had impacted. 3i Atlas is 10 kilometers across, so it is much bigger. So it will leave a much bigger bruise. And there are occasional times where astronomers have detected smaller objects crashing into Jupiter. You get a flash. Sometimes you've seen little bruises on Jupiter. So yeah, it would cause a bruise. It wouldn't last long, like a couple of rotations and the thing would be gone again, but we would definitely see it briefly. And it was an amazing opportunity for science when you think about it, right? Like what we see of Jupiter is really just the cloud tops. We're just seeing the outer layer of the atmosphere of Jupiter. But when this object went in, it essentially excavated a hole in the atmosphere briefly, sort of caused gases that were deeper down to be revealed to the surface. And it was a great opportunity for scientists to be able to study it. And so, you know, to have something 10 kilometers across crash in, that would be amazing. Jonathan Chamberlain, how do we know that the sun has 4.5 billion years left before it turns into a red giant? So we can observe many different stars out there and get a sense of the sort of the life cycle of a main sequence star, of which our sun is an example. And there's a whole system called the Hertzsprung-Russell diagram. There's a sort of well-known sort of categorization system called the Hertzsprung-Russell diagram, and sort of shows the sort of phases that different stars go through when they're in their main sequence phase, and then they can be off sequence when they turn into red giants and so on. But the gist is that, you know, we can see examples of billions of stars at all different masses and all different phases of their lives. And astronomers have various ways that they can actually calculate and see how old various stars are. They can look at globular clusters, which are pretty much as old as the universe itself. And they can see sort of what is the oldest, what is the most massive stars that we see in the globular cluster. And then that tells us, you know, how long will stars live, right? So stars, you know, we don't see the more massive stars in these clusters. They've long since died. You can actually sort of calculate that. We can see examples of star clusters and see where, you know, there are massive stars that are going through the end phases of life, turning into red giants. We know all the stars formed at roughly the same time. So we just have tons and tons of samples to be able to confirm. And then we have a pretty good understanding of how the internal processes of stars work, how long it takes them to run through the fuel in their core before they switch to helium burning, turn into this red giant phase of their life cycle. So, you know, if you could see, like, how do you know that you're going to grow old, right? And how long you generally have to live? Well, you're surrounded by human beings at all different phases of their life cycle. And you know how old human beings tend to live because we've seen plenty of examples of humans dying. And so it's the same thing with stars. Centaurus W. According to Gaia data, more than half of all stars are binaries, 50% of sun-like stars and 75% of more massive stars. Will we send a probe to see if our sun has a binary partner? We don't need to send a probe. We built Gaia. And Gaia, if you know, is measuring the position and movements of a billion stars in the Milky Way. And if there was a star that was in orbital some kind of orbital configuration with the sun, we would detect it, right? It would be obvious if there was an actual star out there that we were a binary star with. I mean, we could see Alpha Centauri. Those two stars are, you know, on the order of tens of astronomical units apart from each other and orbiting around each other. So, you know, like, how far away would this star have to be? Like, at a certain point, it's no longer a binary star with us. Now, people have wondered if the sun has a brown dwarf companion star or a red dwarf companion star. And so there was a mission that came out called the WISE mission, and it was an infrared survey of the universe. And one of the questions that they were looking to answer was, does the sun have a brown dwarf companion? You know, something cool, maybe something with 10 times the mass of Jupiter or 50 times the mass of Jupiter. And it would give off a signature. And they were able to rule it out, that they were able to observe enough of the universe and look for objects that are this, you know, brown dwarf like, and none are in any kind of orbital configuration with the sun. In fact, they were able to rule out a large planet as well. So there's no Jupiters, say 50,000 astronomical units away from us, or within 50,000 astronomical units. Now, that still allows for the possibility of something that is Earth-sized out there. Like if there is a planet 9, it could be Earth-sized, it could be Uranus-sized, any bigger than that, and we would have detected it with the Y survey. So, but definitely no binary star or even brown dwarf. We looked. Benjamin Tunn, I don't know if you're aware, but your live stream audio is much quieter than that of your videos. Yeah, you're listening to the audio before it's been processed by the editors. So the editors go through and do a ton of cleanup on the audio, raise the levels, make it standard for YouTube. In this case, my audio, I am recording it, and I'm making sure that it doesn't go into the yellow as I'm recording it, so it doesn't get overly, too much gain, and then they're able to boost it for the video. So just turn up your sound. James Rudy, did you hear that 3i Atlas just pulled up to the moon and parked? I did not hear that. That'd be cool. Ryan Jewell. Fraser, I'm trying to find a library for PGC, UGC objects to capture long exposure astrophotography at high galactic latitude, and I want to find out what's in my image, know where to look. So my favorite tool is Telescopius, which is a website that allows you to plan out your observing. And they put a lot of really great constraints. You can put a lot of constraints into it. So you can say, I want to look at objects that are located within this part of the sky, only galaxy clusters, maximum magnitude this, minimum magnitude that. You can put a lot of constraints into it. They're pulling their data from various catalogs, and you can go to those catalogs directly. I've played around with trying to kind of query some of the sort of object databases. There's like the Simbad database is a good example. A lot of these have open APIs, so you can query them and say, show me all the galaxies of, this magnitude, blah, 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 that size, this, this many arc, between this many arc minutes and that many arc seconds, whatever. And then it'll pull up a list of objects. And that's what the astronomers, like professional astronomers, use. So check out the Simbad, SIMBAD. Let me confirm. Yeah, the Simbad astronomical database. Try that. But if you like using Simbad and that's like not enough for you, then I have no additional information for you. Jonathan Chamberlain, if Earth somehow left the sun's gravitational influence and we became a rogue planet, how long would humans last, or could we survive? We wouldn't last long. We wouldn't last long if the average temperatures on Earth decreased by just a few degrees. The Earth would enter an ice age. So, if the Earth was flung off into space, then the Earth would immediately enter an ice age. And then all life would die on the surface. Now, maybe there'd be some people who were living in deep underground and they would be harnessing the Earth's internal heat. And that lets you survive for longer. It would take probably billions of years for the Earth to cool down to the point that you wouldn't be able to harness the internal heat. Longer, actually. There's still radioactive decay going on inside the Earth that's helping to contribute to its internal temperature. It'd still take a long time to cool down. So, But if you try to live on the surface, it would be very, very, very cold. Think, on Pluto, they have glaciers made of nitrogen, right? The stuff that's gas in our atmosphere on Pluto moves around on the surface. On Titan, it rains methane. A thing that is a gas here is rain on Titan. So yeah, it can get very cold. Let's see. Come on, little database. All right. Darth X, did 3i Atlas change because people looked at it? No. I don't even know what that means. Jamin Rooney, do you think going to the moon in one shot instead of this refueling in space is a good idea? So the problem that we had with the Apollo missions, which was going to the moon in one shot, was that we didn't go back. That it was enormously expensive, had sort of no financial reason to do it. It was really just a demonstration of the United States' technology and economy, that it was able to, have a human set foot on the moon before the Soviets did. And then there was no reason, they went after other goals. There was no reason to do it. So if we want to be able to go to space, and we want it to be some kind of long-term sustainable, like we stay in space in the way that we stayed on the International Space Station, but now we're on the moon. It needs to be, someone needs to figure out a way to decrease the costs. And building a giant rocket that you completely throw out each time does not really decrease the costs. It's going to still be enormously expensive, and somebody's going to go, boy, we're going to running a deficit again this year. Couldn't we cut that NASA thing? Right? What is having people walk on the moon given us? And people will be like, yeah, I guess you're right. And they just vote, and then it goes away. So there needs to be a way to be able to bring down the costs, and reusing every part of your rocket makes a ton of sense, theoretically. And we've seen cost decreases from SpaceX using a reusable booster stage, first stage on their rocket, right? They've been able to decrease the launch costs down. You can buy a rocket launch from SpaceX for $60 million when it used to cost you $400 million. Using an Atlas or a Titan or something like that. So they've been able to decrease the costs. And theoretically, if we get a fully reusable two-stage rocket, then you will have only the costs of the fuel, which is how like an airplane works, right? Like you don't throw out your airplane every time you fly the airplane, you reuse the airplane. You don't throw out your car every time you drive your car, you just refuel your car. And so we should not be throwing out our rocket every time we use it. We should be refueling our rocket. The problem is that getting a rocket into orbit and then being able to bring it back down to Earth and refuel it is at the very limits of engineering, almost the very limits of what the laws of physics permit for a chemical rocket system. It's like just barely possible. And so the amount of actual propellant you're going to be able to carry up into space is going to be less than if you were willing to completely throw away your rocket. But the upside is that you don't have to destroy your rocket. You've landed your rocket and then you fill it up again and it goes back to space. And refueling has a lot of other benefits that, there are a lot of satellites out there in space right now that are essentially have reached the end of their life because they've run out of propellant. they're fully operational. Every part of them works, but because they don't have propellant for station keeping, they have to be shut down, and they become space debris. And so if we could refuel satellites, that would be incredible. And so you can imagine, the same concept that works down here on Earth, where you have cars that you refuel, you have refilling stations, gas stations, where you refill your car, then you drive to another one, you refill. That concept, that paradigm would work for space exploration, that you would have a place in low Earth orbit that you can refuel a spacecraft, use every drop of fuel to get into orbit, and then you hit the refueling station, you refuel your rocket, and then you head off to another destination, you refuel your rocket, head off to another destination. Like, that model should make space exploration a more sustainable, less expensive, more repeatable system. It's just that technology is all brand new. That although some tests have been done refueling in space, NASA has an experiment on board the International Space Station where they've tested out refueling in space. Nobody has tested at the kind of scale that would be necessary for sending missions to the moon, that you would need to be storing, cold propellant in the vacuum of space. And hydrogen specifically is a very difficult gas to store. Very small molecules. They really want to escape. That you need some way to make sure that you're keeping your fuel at the right temperature in space, which is actually really tricky to do. And so there's like a lot of technical challenges. And so far, the ship that is expected to become the tanker that's going to carry the fuel into space has not demonstrated that it has the reusability, or we don't know if Starship is going to work. So, I think that the idea that you're going to refuel in space is inevitable, that it is obviously the right idea, because you don't have to destroy your rocket, right? But it is a technical challenge. And I think that there's unfortunately, there's too much riding on Starship being successful as quickly as possible. Right now, the Artemis 2 mission is going to launch in just a couple of months now. February? Anyway, it's almost time for the Artemis 2 mission to launch. And then comes Artemis 3. And it's supposed to use Starship as its landing system, but Starship still has not demonstrated that it can be the landing system, and hasn't demonstrated in-orbit refueling. There's a big to-do list that we're waiting on. But that doesn't mean that these technologies shouldn't be worked out. They should absolutely be worked out. People should work on them. It's going to take more time. So if you want to once again demonstrate the economic and scientific might of the United States, they should go with a disposable rocket, boots on the ground, return them safely back to Earth, demonstrate that they can do it. They still got it. But if you want a long-term sustainable system, then you have to invest in all of these technologies and sub-technologies. Mr. AJ Mitchell, recent data shows how plants remember, learn, show problem solving, and communicate with their neighbors. Should I get off my high horse as a vegetarian? Like what's next? What have you got left? If you're a vegetarian and now the plants are talking and are communicating, what do we do? What do we eat? Is it like pluribus? It rocks. DS 8197. Do you think that we as a species will stop the Kessler syndrome? Kessler syndrome, this is the idea that eventually there'll be so much space debris that it's going to collide with each other and into smaller and smaller pieces, and it'll just become impossible to send new spacecraft into space. And that is not a really accurate sort of understanding of what's going to happen with sort of the future of space junk. That, the space junk that is close to the Earth deorbits relatively quickly. And so even if you had a Kessler syndrome close to the Earth, that material would re-enter the Earth's atmosphere within a couple of years, within a decade, and clean it all back up again. It's the stuff that's higher, the stuff that's say 1,000 kilometers altitude, that can last longer, can last a few decades. The stuff that's even higher than that can last centuries. That's stuff you have to be worried about. But then that stuff is also in a much larger volume or much larger surface area where all that material is. And so you're not going to get the sort of common collisions, and then you will always be able to pass through the region. If you're trying to operate a satellite in that area, then you're going to have to maneuver more often. There's a higher likelihood that you're going to take damage on your spacecraft. So there won't be this kind of tipping point that everything just suddenly gets destroyed. It's just that, if you try to operate a satellite in one of these orbits that has got a lot of space debris and there's a lot of impacts, or there's a lot of material there, you're going to either have to expend a lot of propellant avoiding potential collisions, or you're going to have to accept a higher risk that your satellite is going to become part of the problem, that's going to get hit by debris, torn apart, and it's going to become a bigger problem. But if you just want to zip out into space, that will always be relatively safe. Have to be really unlucky. It would have to be really unlucky for your spaceship to be trying to slip through the sort of debris spheres and get hit. All right. We've reached the end of the live stream. So thank you, everyone, for hanging out on this Sunday night for me in Canada, but it's a reasonable time for those of you in Australia and in Asia, and it's morning, it's breakfast for people in Europe. Kenny Mailer asks, what if 3i Atlas had actually hit the Earth in any capacity? What scenario would mankind currently be dealing with right now? If a 10-kilometer comet moving at interstellar velocities hit the Earth, it would be a very bad day. That is the size of the asteroid that wiped out the dinosaurs. So this would be that size, but going at a much higher velocity. So it would cause worldwide destruction, an extinction level event for a lot of life. Right. So thanks to Zapfan and other moderators who showed up to hang out and help out. Thanks in advance to Chad and Anton. I'm gonna have to edit this nonsense together. What do we got coming up? We got an interview we're going to be posting tomorrow, which should be really fun. All about my current obsession. And then that's it. We've got a bunch of other projects we're working on. So I hope you all had a great year, and here's to another amazing year of, while the rest of the world is, going to get crazy, space and astronomy will continue marching on, giving you lots of good news. All right. We will see you next time.